Hey, 4.1, solve one and two-step linear equations. So we're going to use opposite operations, and what that means is they're operations that undo one another. So addition and subtraction are opposite operations, and then we have multiplication and division are also opposite operations. Okay, equations can be solved in different ways. So when we go through this, just know that this is not the only way that they can be solved. Okay. But one way to check to a linear equation is to substitute the solution. Let's go. Check a linear equation is to substitute the solution into the original equation. Okay, and if the left side and the right side of the equation have the same value, the answer is correct. Okay, example 1, solve each equation. So we have x plus 3 equals 7. So we need to get the x all alone. So the opposite operation to plus 3 is minus 3. So we're going to subtract 3 on the left and subtract 3 on the right. Okay, the 3 minus 3 cancel and we're left with 7 minus 3, which is 4. Okay, 3y equals negative 21. So the 3 and the y are multiplied. The opposite of multiplication is division. So let's divide both sides by 3, and these 3's cancel out. What we're left with is negative 21 over 3, which is negative 7. Case C, m over 2 equals 5. So right now the m is divided by 2. So the opposite operation is multiplication by 2. So we're going to multiply both sides by 2. And if we take 2 over 2, they cancel. So we're left with m equals 5 times 2, which is 10. Okay, 12 equals h minus 1. We need to get the h all by itself. So this negative 1, we're going to add 1 to each side, because 1 minus 1 cancels out. So we're left with 12 plus 1 equals h, so h equals 13. Okay, example 2, solve each equation. Okay, so we're going to keep going. 12 equals negative 3x. We need to get the x all by itself, and it's multiplied by negative 3 right now. So I'm going to go ahead and divide both sides by negative 3. Okay, I get x equals, it's 12 over negative 3, which is just negative 4. Okay, x over negative 5 equals 1. Right now, the x and the negative 5 are divided, so we have to go ahead and multiply both sides by negative 5. I'll bracket that so we know it's not subtraction. So this negative 5 over negative 5 cancels, and we're left with 1 times negative 5, which is negative 5. Okay, negative 4 equals x minus 4. We have to get this negative 4 away from the x, so we're going to add 4 to both sides. Those cancel. We have negative 4 plus 4, which gives us 0. X minus 1 equals 5. The opposite operation of minus 1 is going to be plus 1. So we're going to add 1 to each side. And we're left with x equals 5 plus 1, which is x equals 6. Okay, E. So these are starting to have two steps. So first, we do the plus and the minuses. Okay, so we need to get this plus 5 away from the 5x. So we're going to subtract 5 from both sides. So we have 15 minus 5 equals 5x, which is 10 equals 5x. Now, what we can do is we can divide both sides by 5. So those cancel. Okay, we get x equals 2. Okay, 4x minus 1 equals 1. This negative 1, I'm going to add 1 to both sides. So those cancel. And we get 4x equals 1 plus 1. So we get 4x equals 2. Okay, we have to do the opposite operation of multiplication with this 4. So divide both sides by 4, and we get x equals 1/2. Right, 2 over 4 is just 1/2. Okay, 2x over 3 equals 4. So let's do the divided by 3 first. So the opposite of division is multiplication. So we're going to multiply both sides by 3. Those cancel out, and we're left with 2x equals 4 times 3, which is 12. Okay, now 2 times x, we're going to actually divide it this time. Okay, opposite of multiplication is division. So I get x equals 6. Okay, same thing with this question. Negative 6 equals negative 2x over 5. So negative 2x is divided by 5. So let's multiply both sides by 5 right now. So we get 5 times negative 6 equals, and then these 5's cancel out and we're left with negative 2x. So we get negative 30 equals negative 2x. Now we're going to try to get the negative 2 off of the x. So divide both sides by negative 2. And I get x equals 15. Okay, we have x over 2 minus 1 equals 5. So this minus 1 we'll deal with first. We want to add 1 to both sides. So we're left with x over 2 equals 5 plus 1, which is x over 2 equals 6. Now, divided by 2, we do the opposite, so we multiply both sides by 2. Those 2's cancel, and we get x equals 12, right? 6 times 2 is 12. Okay, negative 3x divided by 11 equals 9. I'm going to first deal with this divided by 11. So we're going to multiply both sides by 11. And I'm left with negative 3x equals 99. Okay, because 11 times 9 is 99. Now we're going to divide both sides by negative 3. And I get x equals negative 11. Okay, we got 4.5 equals 0.5x minus 2.5. We're going to take this negative 2.5 and we're going to add 2.5 to both sides. Right? So we have 4.5 plus 2.5 equals 0.5x. So we have 7 equals 0.5x. And we're going to divide both sides out by the 0.5 so that those cancel. And we're left with x all by itself. And we get x equals 14. Okay, now we're going to do the exact same thing in example 3, but we're just going to check our solution afterward. Okay, so we have 3k over 4 equals 9. So I always get rid of this, like the fraction first. I don't want to deal with fractions. So if we're divided by 4, we're going to multiply by 4, both sides. So we get 3k equals, and then 9 times 4 is 36. Now I'm going to divide both sides by the 3, and we get k equals 12. Okay, how we check that is we take the equation, the original, and we don't move anything over, we just sub in the answer. So I subbed in for the k 3 times 12 over 4. So 3 times 12 is 36, and I'm going to write over 4 equals 9 just as it is. Okay, now 36 divided by 4 is 9 equals 9. Therefore, left side equals right side. Therefore, our answer is correct. Okay, example 4, the graph shows the relationship between the volume of gas in cubic centimeters, which is in Y, right? Volume of gas here, and the temperature in degrees Celsius, which is our X value. So we're going to go ahead and write an equation in the form y equals mx plus b, and then state what m and b represent. Okay, so we've done this so far, and then we're going to actually do some algebra in B. So the slope is going to be, we're going to go from this point here to this point here. So we're going to go rise over run. So the rise is going to be from 455 to 500. Okay, so we'll go 500 minus 455. And the run is going to go from 0 to 27. So backwards, 27 minus 0. And we get 45 over 27. Okay, what do the values of m and b represent? Oh, our b value is actually right here anyways. It comes straight from this. It's just 455. So m represents, and what we do is we take the numerator and the denominator and we apply it to volume of gas. Okay, that for every 45 centimeters cubed of gas, increase, because it's positive, there is 27 centimeter or degrees. There is a 27 degrees Celsius increase in temperature. Okay, now B. What does the B represent? At 0 degrees Celsius, the volume is 455 centimeters cubed. Okay, now find the temperature at which the volume of gas is 725. So I would, oh, we didn't even make the equation. Let's make the equation first. So y equals 45 over 27x plus 455. And now let's sub in 725 centimeters cubed. Well, if it's centimeters cubed, we're talking about the y value. Okay, so 725 equals 45x over 27 plus 455. Okay, and this is where our algebra comes into place. So this 455, we're actually going to subtract 455 from both sides. Sorry, I'm going to go back over here. Okay, so we have 725 minus 455 equals 45x over 27. Okay, so 725 minus 455 is 270 equals 45x over 27. So we want to get rid of this fraction, so we're going to multiply both sides by 27. Okay, and we get 7290 equals 45x. Now we can divide both sides by 45, and we get x equals 162. Okay, so therefore, at a temperature of 162 degrees Celsius, the volume is 725 centimeters cubed.